Hey guys, what's up? We're back with day 93. Today we're looking at solution curves and the big part of this standard, which is solving differential equations, which I call diff-EQs. So one of the things that the AP exam might ask you to do is plot a solution curve. Okay, and what they'll do is they'll give you a point and then you have to plot the solution curve. So let's take a look at an example. Here is a slope field. Hopefully you can see that okay. Here's a slope field, and what I want you to do, what they might ask you to do, is plot the solution curve through the point 0, 1. Okay, they'll say, draw a solution curve. Through the point 0, 1. So the first thing you want to do is plot the point 0, 1, okay, which means 0x, 1y, so it'll be right here. Then what we do is we use this slope field to kind of guide our line. And we need to extend it both to the right and to the left. We want to extend it for the whole picture, whatever the picture frame is given here. So if I wanted to plot this thing, right, the slopes that are going on right at 0 are pretty flat, looks like a horizontal slope. And then I just kind of follow the line. So it looks like something like this, going to the right. Going to the left, then, it kind of looks like this. Oops, didn't mean to do that. So there we have a solution curve. Okay. If you take a look at that solution curve, what does that graph kind of look like? Well, it kind of looks like the graph y equals x cubed, right? So maybe the solution to our differential equation is a y equals x cubed solution. Okay. Let's try it through another point. I'll use a different color. This time let's try the point 1, 0. So if we also want to do it through the point 1, 0, that's a different point. That point is right here. And once again, I kind of want to follow where the lines are telling me to go. Okay, so there's a different solution that goes through a different point. Okay. Again, the graphs look pretty similar to each other. They both look like x cubed graphs. Let me show you another example of what I mean. I think these are kind of easy to do. They're a little bit weird. You don't have to worry about being perfect. You just want to follow the general shape of the sloped lines. Here's another one. This is kind of a fun slope field. You can imagine right away if I asked you, what shape are you going to be drawing here? What do you think? Let's try a solution curve through the point 4, 0. So again, I want to plot 4, 0, and I just kind of want to follow the general shape that's going on here. It would be maybe something like that. Right? It's looking more like a circle. Now, if it really was a circle, I probably should go through 4, -4, -4, maybe more like something like that. Right? Or if I want to do the solution curve at the point 0, 2, again, these solution curves are looking like circles, so it would be something like this. Okay? Don't worry too much on these. You just got to kind of get the general shape going on. Okay, that's step 1. When we get those ones, it should be a pretty easy point. The next thing I want to do is look at solving differential equations, okay? So this is the meat of the standard. So let's take a look at it. First off, I'm going to give you a solution, or I'm going to give you a differential equation. Okay. So let's say that that's our differential equation. And what it's going to say is, find the solution y equals f of x for the differential equation that goes through f of 1 equals 2. Okay, so just like conceptually thinking about this problem, what they give me is dy dx. What I want is y, right? I want y equals f of x. So to go from dy dx, which is a derivative, back to the original function, I know that this is going to be an integral type problem. I'm going from derivative back to function, right? I'm going to have to do an antiderivative here. The problem is we have both x's and y's in here. So what we have to do is figure out a new method for doing this, okay? We also have a point, f of 1 equals 2. Okay, so to solve these things, we're going to go through, I don't know, I think it's like 5-step process. So step 1, we want to separate. So I want to separate my x's and my y's, okay? And I'm always going to do this by multiplying. I'm going to break up that dy dx. I'm going to multiply dx to the right side of the equation, right? To get rid of this dx here, I need to multiply it because it's on the bottom. And then I got to do whatever I can to get y to the other side. Just letting the equation guide me there. So I'm going to do twofold things here. I'm going to separate this by multiplying the dx over. Then I have 3x squared dx. I want to get this divided by y out of here, so I'm going to multiply y to the other side. So after I separate, I get this. Y dy, right? That y multiplied over, so I have y times dy, equals 3x squared dx. So when I say separate, that means get the y's with the y's, get the x's with the x's. Okay? So that's step 1. Step 2 then is to integrate. So we separate, integrate. Okay, that's our first 2 steps. Now we're going to do indefinite integrals here, and generally when we do indefinite integrals, we have to add a plus c. We're only going to do that in one place. I'm always going to do my plus c just on the right side. Now in actuality, a constant comes out of both of them, right? We don't know what those constants are. We're going to figure them out based on the point given, okay? But instead of having 2 different constants, I can just subtract one constant over to the right side and get a new constant. So really there are 2 constants, but we're just moving them all to the right side. Okay, when we do our definite integrals here, we don't have to worry about anything other than just making sure y stays y and x stays x. So our next move here is we want to integrate both sides. Now, what would be the antiderivative then of y dy? Well, that's just a simple bump and divide. I'm going to bump it up to y squared and divide by 2. So I'm going to get 1/2 y squared. That's the antiderivative on the left side. I'm not going to put my plus c on the left side. I'm only going to put a plus c on the right side. Okay? So I have that on my left. On my right, on my right side, I need the antiderivative of 3x squared. Well, I'm going to bump and divide. 3 divided by 3 is 1. And now I put my plus c. So I'm going to change step 2 just from integrate to integrate plus c. Okay. By the way, when you have to do these on the AP exam, they're worth a lot of points. And if you don't separate as your first step, you can't get any points on the problem. So make sure you separate. Even just by separating, if that's all you can do, you get a point. So make sure you separate the variables. Now I have to identify what this C is going to be. So step 3 is plug in and solve for C. All right, so I'm going to plug in my point. My point, as a reminder, this is my X, this is my Y. So I'm going to plug in my X and my Y to figure out what C is. So, taking a look at the point is the point 1, 2. So 2 is going to go in for Y. 1 is going to go in for X. Now I just have to solve for C. 2 squared is 4. 4 divided by 2 is 2. So 2 equals 1 plus C. Solving for C then, I have to minus 1. I get 1 equals C. Okay. Step 4. Replace C and solve for Y. Now, you must solve for Y equals f of x. Because it says it up here. Find the solution Y equals f of x. So what we have to do now is plug in the C we get, and we have to get Y alone. So we got to use all those old math skills that we have from before, and we have to think and solve for Y. It must be in Y equals form. When we write equations of lines, we don't have to have in Y equals form, but here we do. They're very specific about that, so make sure you do that. So I'm going to replace C. So looking back at this equation, I now know what C is. So I'm going to rewrite this whole equation, but where I see the plus C, I'm going to write 1. Uh-oh, I'm related. So I'm going to have 1/2 y squared equals x cubed. Instead of plus C, I'm going to put plus 1. Okay. Next, I'm going to solve for y. So I got to get to say y equals. So I got two things I got to take care of. I got to take care of the 1/2, and I got to take care of the squared. Both of those things have to go away. Okay? And we have to be really careful when we undo a square. So the first thing we want to do is get rid of the 1/2. So I'm going to multiply the whole equation by 2. When I do that, I get y squared equals 2x cubed plus 2. Make sure you multiply, right, the whole thing on each side by 2. Okay? Now, when I ask people, how do we undo a square, right? The most common answer is a square root. Okay? We have to be very careful. If y squared equals something, y could either equal the positive square root or the negative square root. Right? And oftentimes they wanted, in math, right, if I told you x squared equals 9, I'm looking for x equals plus or minus 3. Right? Because it could be either one. But here I'm looking for specifically one or the other. So we need to be very careful, and we're going to use that initial condition, right, that point we have to help determine. Okay? So here's what we do. I'm going to write this. Y equals the square root of 2x cubed plus 2. But again, right now, I don't know, is this plus? Is this minus? It can't be both. You can't write y equals plus or minus root 2x cubed plus 2. It can't be that way because we can't have two solutions. There's only one solution. It's either plus or it's minus. Okay? It's got to be one or the other. So, how do we determine which one it's going to be? Well, let's plug in our initial condition at the point 1, comma 2, and see what happens. I plug in 1, 2, 2 equals square root of 2 times 1 cubed plus 2. 2 times 1 cubed is 2. 2 plus 2 is 4. The square root of 4 does equal 2. Because this equation works with the positive square root, I'm going to leave this as a positive square root. We don't need to write the plus in front. By writing nothing, it's implied that it's a plus. Okay? But if my initial condition was 1, comma negative 2, then negative 2 wouldn't equal the square root of 4. It would have to, negative 2 would equal the negative square root of 4. So that's how we'd know to put a negative out front. Okay? There are lots of little touchy things with this that we can go through. Okay? But there's our answer. Y equals the square root, the positive square root of 2x cubed plus 2. That is our solution. I'm going to show you one more. I'm running out of time here, but I want to show you one more that has another little tricky aspect to it. Okay? So here is my problem. So we have dy dx, and we want to find the solution y equals f of x. Through the point f of 0 equals 1. Okay? Actually, let's make it more interesting. Let's do f of 0 equals negative 1. This will be a more interesting problem. Okay, so what's step 1? Well, step 1 is separate. So I'm going to multiply the dx over, and I'm going to get dy equals y sine x dx. How am I going to get the y to the other side now? Well, now I have to divide the y. So I end up with this. dy over y equals sine x dx. Okay? Now I have to integrate both sides. Integrate, integrate. Now you might say, well, what the heck is the integral of dy over y? Well, what's another way of writing dy over y? Well, we could call it 1 over y dy. For some reason, people see it better when they see 1 over y dy. This is a natural log, right? And now here's where we have to be very careful. It's the natural log of the absolute value of y. Okay? I don't put my plus c on the left. I only put the plus c on the right. On the right side here, I'm going to integrate sine x dx, which I know is negative cosine x dx. Or negative cosine x, sorry, plus c. Okay. So there we have it. Now I have to solve this thing. Okay. Or sorry, I gotta plug in and find my c. So here's what I'm going to do. Again, this is my x. This is my y. So I'm going to plug in ln absolute value negative 1 equals negative cosine of 0 plus c. Right? I got that. Yep. Negative 1 went in for the y. 0 went in for the x. Now, the absolute value of negative 1 is positive 1. And ln of positive 1 is equal to 0. Cosine of 0 is 1, so this becomes 0 equals negative 1 plus c. I add the 1 over and I get c equals 1. So c ended up being 1. So what I'm going to do is plug this thing in, and I'm going to get ln absolute value y equals negative cosine x plus 1. Okay. Now all I have to do is solve for y. But what a lot of people worry about is, what the heck do I do with that absolute value? Okay. Well, let's worry about the absolute value in a second. How are we going to get rid of natural log? So we get rid of natural log with e. It's the inverse of it. So what we're going to do is we're going to raise both sides of the equation. We're going to raise them as powers of e. Well, e to the ln absolute value y is going to be absolute value y. And this will just be now, what do we do now? Some people, a lot of times students just drop the absolute value and they say y equals e to the negative cosine x plus 1. Okay. But let's see if we can do that. Okay. So here's the deal with absolute values, right? It makes what's inside there could be plus or it could be minus, right? So let's say the right side of the equation equaled 5. Y could be 5 or negative 5 and it would work, right? So we have two options here. Y could equal e to the negative cosine x plus 1, or negative y could equal e to the negative cosine x plus 1. Let's just test the first one. Let's test what happens if we just dropped it. Plug in my point. Again, the point was 0, negative 1. Let's see if this works. Does negative 1 equal e to the negative cosine 0 plus 1? Well, negative cosine 0, again, is negative 1. Negative 1 plus 1 is 0. E to the 0 equals 1, so I get negative 1 equals 1. Is that true? Absolutely not. So the actual answer will be negative y equals e to the negative cosine x plus 1. Now, I can't leave it like this because it has to be in y equals form. So I'm just going to divide both sides by negative 1, and I'm going to get y equals negative e to the negative cosine x plus 1. Now again, I should test this to make sure it works. Again, I'm taking the point 0, plugging it in for x, and negative 1 is going in for y. And now I get negative 1 equals negative e to the 0. E to the 0 is 1. I get negative 1 equals negative 1, which is true. So here is my answer. Oops, sorry. That's wrong. That's not my answer. This is my answer. My final answer is y equals negative e to the negative cosine x plus 1. I'll show you some shortcuts for determining that in a later video, but that's the long and the short of it right there. Okay. As you can see, we're going to be doing lots of integration here, lots of practicing integrals. It's a good standard to do right before the test, because we're really practicing all of our integrals again and antiderivatives and all that fun stuff. That's it for today. I'll see you guys on Monday. 2 chains, bye.